How many people got a chance to get started on this? Okay, so I'm going to give you a couple more minutes to try this one here. Remember what we're looking for in this one. We're trying to find the net force acting on the Earth due to the gravitational pull of the sun and moon. All right, so there's a force of gravity between the Earth and the moon. There's a force of gravity between the Earth and the sun. Okay, and we need to find the net force as a result of those two forces, which you can calculate. All right, so I'm going to give you a few minutes to do that one, okay? Because this is one, guys, that, like I say, I can't remember the last time I didn't have a question just like this on the unit exam. Okay, it's not very difficult, right? But it does take a little bit of calculating. All right, so there's two forces acting. There's the force of gravity pulling the Earth towards the sun, okay? And then there's the force of gravity pulling the Earth towards the moon. Okay, so we got force of gravity between the moon and the Earth, force of gravity between the sun and the Earth. I have to calculate both of those forces before I can do anything else. All right, so the force of gravity between the sun and the Earth will be, okay, 6.67 times 10 to the minus 11 times 1.99 times 10 to the 30, that's the mass of the sun, okay, times 5.97 according to them, okay, times 10 to the 24 kilograms, that's the mass of the Earth, divided by 1.50 times 10 to the 11 squared, and that's the distance between the center of the Earth and the center of the sun. Okay, so if I do that, I should get around 3.53 times 10 to the 22, but we'll actually get the number here. Oh, sorry, 5.97. Okay, so we got 3.52, 3.5218, we'll see. Okay. Newton, sorry, that's times 10 to the 22 newtons, okay, and that's toward the sun. Then I've got to do exactly the same calculation for the force of gravity between the moon and the Earth, so that'll be 6.67 times 10 to the minus 11 times 5.97 times 10 to the 24, okay, mass of the Earth, times 7.35 times 10 to the 22, the mass of the moon, divided by 3.84 times 10 to the 8 squared. That's the distance from the center of the Earth to the center of the moon. All right, so if we take that, actually we'll just do this, we'll go minus, another brackets. Okay, I think I got the right number of brackets there, hopefully. Okay, so we get 3.50 times 10 to the 22 newtons towards the sun is our net force. Okay, so to calculate the net force, all I did was take the force of gravity between the sun and the Earth and subtract the force of gravity between the moon and the Earth, right? Because they're pulling in opposite directions, right? So all I had to do was that simple calculation there where I put in the two gravities I had calculated and subtracted them, and then I had the answer. Okay, it's not a difficult question. You don't even have to really manipulate anything to answer that one. Okay? But like I say, I've almost always had a net gravitational force question like that on the unit exam. Okay, questions on what we did there? Okay. I want you guys to try these two. Number one is quite easy. It's very similar to what we just did. Number two is a bit more involved. so try number 1 first. Okay, all we've done is switch the moon from one side of the Earth to the other. Okay, so what do we do different for question number 1? We add them instead of subtracting them. They're both pulling the Earth towards the sun now. Okay, so we use exactly the same numbers we used in the last question. We just add them together. So we get 3.52 or 3.53. Okay, sorry, they have 3.54. Okay, 3.54 times 10 to the 22 newtons towards the sun. Okay, on this one. All right, here's where it gets not a whole lot trickier, but it makes you remember some vector stuff. Because now the moon is off 90 degrees to the side. Okay? Still, same forces. You don't have to recalculate the forces. Whatever you got for the numbers in the last 2 questions, it's still those numbers. The force of gravity between the Earth and the moon doesn't change. Force of gravity between the sun and the Earth doesn't change. But their vector sum does. All right? So now you've got to figure out what the vector sum of those 2 forces will be. Okay? Now that the moon is off to the side. Remember how to draw vectors. We draw them tail to head. All right. All right. So in solving this one, guys, we'll take our force of gravity between the sun and the Earth, okay, pointing towards the sun, and then we'll put on the head of that the one between the moon and the Earth, which even that is not really to scale because by comparison, it's tiny. It's less than 1/100th of what the force of gravity is between the sun and the Earth, okay, which is why the moon orbits the Earth and not the other way around, okay. So this is the force of gravity here between the moon and the Earth, and when we get that, we get this incredibly slim triangle where the hypotenuse is virtually the same number in terms of magnitude as that adjacent side, and the angle is 0.3 degrees. It's tiny, okay. So once I have these 2 sides here, okay, then I can just use trigonometry, tangent in this case, okay, to get the angle, and then I'm good to go. I use Pythagorean theorem to get the hypotenuse. Like I say, it doesn't make the hypotenuse change very much, okay? In fact, you have to go back several decimal places for there to actually be any difference, okay? Because the moon's effect is so small. Now, I was telling you the other day that the Earth does wobble back and forth in its orbit. I drew it, of course, greatly exaggerated, but it does wobble, and this is showing that yes, there are some vectors here, there are some forces involved. They might be small, but they're there. Okay. All right, questions on those ones? Okay. All right, I want you guys to do a couple of practice problems off of the worksheet here, just on force of gravity. And then on Monday, we'll be starting into satellite motion. Okay, so that stuff will all be coming up. Don't forget about all this other stuff too. Okay, we'll do our unit exam review next week. Okay, because we got satellites and gravitational fields, and then that's it. That's all there is left in this unit. So we'll do our unit exam review next week, but remember that that's coming up as well. Okay, you can. All right, so I'll put the sheet up here, guys, and that's what I want you working on. Oh, I picked up the pen. Yes, you may. Where did I put the pen? Okay, guys, so there's what I want you working on. Okay, let's get to work on those. Okay, so for number 3 here, guys, we're told what the force of gravity is in this question. Okay, we're told it's 2.30 times 10 to the minus 8 newtons. Okay, we're told the objects are 10 meters apart, so that's our radius. Okay, and we're looking for the mass of each object. Now, here's the thing. It says the objects have the same mass. So it's a bit of a math trick. Okay, Fg is big G times mass 1 times mass 2 over r squared, except that mass 1 and mass 2 are the same number. So it's really like saying mass 1 times mass 1, which would be the same as mass 1 squared. That's the trick, is that I'm actually only solving for 1 variable when it seems like I'm solving for 2. So now I just have to isolate this mass. So I multiply both sides by r squared, divide both sides by big G, and then square root. And that'll give me that mass because they have the same mass. So it's a math trick. It's not really, yeah. Okay, any other ones? Okay, keep going.